We are going to simplify radicals today. Radicals today are square roots, okay? Remember that the square root of a number, right, is asking you what number multiplies by itself to equal n. So, for example, the square root of 64 is 8. The square root of 81 is 9. How about I make that a 9? Okay. We're going to make a list of the first 20 perfect squares. You should have those memorized at least up to 20. Okay. You probably already have the first 12, hopefully, memorized. So 1 squared is 1. 2 squared is 4. Yes, I highly recommend writing these all down. 3 squared is 4 squared is 5 squared 25. 6 squared. I'm just trying to save space. You're more than welcome to just write it down the whole side of your paper, but I want it all to show on one slide here. 7 squared is 49. 8 squared is 64. 9 squared is 10 squared is, and 11 squared, 12 squared. This is where we get into less people responding. 13 squared, 169. 14 squared is 196. 13 and 14, you swap those numbers. And 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Okay. Knowing these will help make this go faster, right? Because some of your problems are going to have a perfect square answer, and you got to recognize those. Oh, that's a perfect square. Most of you probably have up to 12, maybe 13 memorized, right? So that's only like a couple more numbers to have committing to your memory, but it will help you. Okay. So we are going to talk about the product property of square roots, as well as the quotient property. It says if the square root, well, just erase the if part. Basically, the square root of a times b is equal to the square root of a times the square root of b. So I can split up square roots by products. The quotient property of square roots says the square root of a divided by b is the square root of a divided by the square root of b. If I can square the top and square the bottom of a fraction, I can take the square root of the top and the square root of the bottom of a fraction. That the square root of 64 is equal to 8. Okay? The square root of 64 is because 8 times 8 equals 64, right? And so that equals 8. One of the ways we show simplifying square roots is looking for pairs of prime numbers. Pairs of any numbers. Okay. So we're going to start by the square root of 45. And we want to break this down into the product of factors. 45, what two numbers equal 45? 9 and 5. Can I break 9 down further? 3 times 3 times 5. Do I have a pair in here? A pair of 3's, right? So the square root of 3 times 3 is 3 square root 5. Remember, the square root of 64 is 8 times 8, so the square root of 64 is 8. Right? The square root of 3 times 3 is 3. Good? Good? You did this in geometry. Yeah. You made the Christmas tree. Okay. So the reason I don't love the Christmas tree is because we did not do the Christmas tree for a reason. Okay? We sometimes lose factors in the little branches at the top. That's why I don't love the factor tree is what it's called. Right? The prime factorization tree. I don't love it because sometimes we lose our factors in the short branches in the middle of all the other stuff. So I just write it out in a line and look for my pairs. Let's look at the square root of 96. All right, so 96 isn't one of those numbers that we immediately know big factors of, but I know if it's even, it's divisible by what? 2. So we can start by that. 2 times what is 96? 48. Yeah. Okay, now I can break 48 down, right? 48, 2 times, what two numbers multiply to get 48? No. 24 and 2. Okay. If all else fails, we can go to 2 times 24. It's 6 times 8, though, not 6 times 7. Sorry if you said that and I didn't hear it. And now it's 2 times, what's 24? 12 and 2. Or 6 and 4. The point is, it doesn't matter how you get there. We're just going to break it down into its prime factorization. And that's 2 times 2 times 2. Right, there's my 3 2's. Now 12 is 2 times 6. I'm going to go to the next line here. No, it's all times 2's. 2. 1, 2, 3, 4. 2 times 3. Wait, nope, that's too many. There's 5 2's. No, we don't need to go back and multiply them back together. We need to find pairs of 2's to pull out of the square root, right? Pairs, the square root of a number times itself is that number. Yeah. So how many pairs of 2's do I have? 1, 2 pairs of 2's. Yes? So it's 2 times 2. That's this 2. And that 2. Square root of what's left? 2 times 3. So outside, 2 times 2 is what?
4.
And inside, 2 times 3 is 6. 4 square root 6.
Oh, my goodness.
Okay?
That was like, I really hope that we don't
Yes, there is. If you know your multiplication a little bit better, okay, there is a faster way to do this, but I need to show you the way to get there no matter what the number is, whether you know those perfect square factors of the number or not. Another way to do this problem, I'm going to come back up here. Yeah. The square root of 96. Yes, I'm going to show you a faster way if you know. What two numbers multiply to get 96? 2 and 48 is not going to get me there quickly. But 16 times 6 does. Square root of 16 is 4 times 4, right? The square root of 4 times 4 is... You can write them separate or you can write them together. Which is then just 4 square root 6.
Why would we not start with that?
Because, did you know?
2 lines with 1 example.
Did you know off the top of your head that
No, I did
16
not.
times 6 was
I
96?
don't want to spoil it for anyone.
If you did, then you can go that route. But if you don't, you might have to break it down to get there.
So how come for this one we had to, or for this one we only did the 4 times the 4 is going to equal the 4, but on the other one we did 2 times the 2.
But this makes sense.
What? Because I already have 2 of the same number. So here I already have 2 of the same number, so why break it down more?
Well, I'm confused though because like on the...
Okay, if we can take apart 2 square roots, we can put them back together.
15 times
Okay? But it's kind of counterproductive to make it 150 and then break it back down again as 15 times 10, don't you think? How about we put them together as products? 15 is 3 times 5. And 10 is 5 times 2.
Oh, okay, wait, I'm not stuck anymore.
Now I have the square root of 3 times 5 times 5 times 2. I have a pair.
Yes, that's 25.
That's, no, well, the square root of 25, but it comes out of the square root as a 5. 5 square root of 3 times 2,
Okay.
5 square root 6.
Oh, I love it. I hate it. Alright, I like that. I got confused at first. So you wouldn't put it separately, but I'll put it as a...
Okay. We have 3 square root 12. That 3 on the outside is just going to multiply by whatever comes out of the square root. Here again, we want to use 4 times 3, right? We can use 6 times 2, but that doesn't get us there fast, right? If you can think of a factor that is a perfect square of the number, you want to look at that first, right? So 3 times the square root of 4 times 3. Yeah, we multiply but what we bring out by what's outside. So that's a pair, 2 times 2, right? So 3 times the 2 times the square root of 3. 6 times square root 3. Now, if you were to get it and say, oh, that's 6 times 2, that's okay. You can just write that as 3 times 2 times the 2. There's your pair, and we end up at the same spot. Okay? So there's lots of ways to get to the right answer. Okay, so now we're looking at the quotient property. If I have the square root of 4/9, the quotient property says I can take the square root of the top and the square root of the bottom separately. And the square root of 4 is what? And the square root of 9 is? And there's my answer. Right. Now what if they're not both perfect squares? We have a math rule.
Why do we add fractions? Don't you have to take out the denominator?
Yes, we cannot have a square root in the denominator.
So doesn't that mean you multiply by the square?
So we have to rationalize it. It's called rationalizing the denominator because an irrational number is a square root that can't be done. And so it does not repeat. It's a decimal that does not repeat, continues. So if I'm simplifying this, I can start like I did the first problem, the square root of 9 over the square root of 2. And the square root of 9 is 3. So I have 3 divided by the square root of 2. But we're not allowed to leave square roots in the denominator. So we have to rationalize it by making it not a square root. I'm going to do that by multiplying by 1. What do you mean multiply by 1? When we are making equivalent fractions, we're doing that by multiplying the top and the bottom by the same number, which means we're actually multiplying by 1. If I'm taking 2/3 and getting a common denominator, I multiply by 3 over 3, right? Isn't this 1? You have to always multiply by 1 so that you keep the value of the number the same, but it looks different. So if I multiply by the square root of 2 over the square root of 2, I'm not changing the value of my number, but I'm changing the way it looks. And what is the square root of 2 times the square root of 2? No, 2. The square root of 2 times the square root of 2 is 2.
Yeah, yes, wait.
Isn't that the square root of 4?
You're right.
Isn't the square root of 4 2?
Wait, what's the square root of 2?
The square root of 2 is square root 2. It's like 1.41, blah, 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 blah.
Okay.
It's irrational. The top is 3 square root 2. So it's 3 square root 2 over 2.
Another one.
We also cannot leave an entire fraction under the radical. Has to be separated and rationalized. Okay. So square root of 1 over the square root of 3. What is the square root of 1? 1. It is 1. 1 over the square root of 3. What am I going to multiply by to rationalize this? Square root 3 over square root 3. Okay. And I get square root 3 over 3. Okay. That's the answer. That's my answer.
Oh.
Yes, there are. So can we just put them together?
Oh, we can. Oh, yeah. 50 over 3. Yay. 6. Well. Oh, we have a pair. Or you cancel out the denominators.
The denominator is a pair, right? So the square root of 3 times 3 is 3. And the top is, oh wait, yeah, hold on. It is times 2.
Silly Billy.
What?
So 5 square root 2 over the 3.
That's right.
I'm not perfect. I do make mistakes, as I just did. Okay, so this is more of the product property, but now we have 3 radicals. We're multiplying them together, and there's a number in front. So we're going to simplify each radical separately. So what's the square root of 12? Can't I say 4 times 3? And the square root of 4 is 2, so 2 square root 3. You can write the 2 times 2 if you'd like. Did I go too fast? Hold on. That's the square root of 2 times 2 times 3, right? Which is 2 square root 3. Let's look at 32. There are several ways we could say 32. 8 and 4. 2 and 16. 2 and 16 is the best way to see 32 when I'm simplifying the square root.
Oh shoot, I think I did something wrong.
Because that's 4 times 4. 4 square root 2.
Oh yeah, I did something wrong for sure. I got 4 square root of 8.
And 2.
Hey, farmer, pay attention, okay?
And 224 is what?
12 times 2?
Or 12 times 2, what else?
6 times 4.
I happen to like 6 times 4. Why?
Because both of them.
4 is a perfect square, right?
Oh.
So it's 2 times 2 square root 4, or square root 6, which is 4 square root 6.
My brain is understanding. Wait, so what do we do now? I'm making a mess.
Okay, so we are going to multiply together what's in front. So 2 times 4 times 4, that's 8 times 4, which is 32. And then we're going to multiply together what's underneath. 3 times 2 is 6. Can't I just write it as 6 times 6? Because there's my pair.
Yeah.
So that's 32 times 6. Or I can write it as the square root of 36 if I want. And 32 times 6 is 192.